Hey everybody, how you doing? If you're watching this on Sunday, happy Sunday, and I hope you're having a great weekend. If you're watching this on Monday in class, just look up and say, "Hey Elliot, hey guys, how you doing?" So today is day one of a 3-day lesson, and it's called Rational Function Transformations. And the first thing we got to do in these problems, or that I have to do, is in order to graph a rational function, you need to know what the parent function is of a rational function, or excuse me, a parent function of y equals 1 over x. Now, if you'd like to figure that out on your own, you should stop this video and go to March 6th on the calendar on my website and fill out this investigation on rational functions investigations, part 1. You could also just, I have both this worksheet and the answer key on my website, so you can try it out on your own. If you don't want to do it by yourself at home on Sunday, we'll be doing this worksheet in class on Monday. So your choice. You can do it right now, or you can do it on Monday. But the whole purpose of this investigation is to figure out what does this parent function look like. And now we're pretending that we've already done the investigation, and this is what it looks like. This particular parent function has two asymptotes, both a horizontal asymptote, like we saw when we did graphed 2 to the x, and a vertical asymptote, like when we graphed y equals log of x. And like always, you need to label those asymptotes. One of them is typically at y equals 0, the horizontal one, and the vertical one is typically at x equals 0. And then, as you saw in the investigation, the graph looked like this. And there's only two key points you have to worry about. This key point, which is at 1, 1, and this key point, which is at negative, not negative 1, 0, negative 1, negative 1. And that is what the parent function looks like. You got to have the vertical, you got to have the horizontal asymptotes. You have to have the graph with these two key points labeled. All right, so the first graph I'm going to do using transformations, and we're only, because it's day one, we're only going to do translations today. We'll cover dilations and reflections over the next couple days. But I have a graph, a 1 over x graph that looks like this, and we need to graph it, and we need to include the domain and range. We'll get to the domain and range in a minute. First, just the graph. Now, this graph is going to look identical to this graph. There's going to be a horizontal asymptote. There's going to be a vertical asymptote. You just got to figure out where they're at. Now, because of this x minus 4, this is considered inside the function because it's where the x is. So it's going to go left or right. And as always, you do the opposite of what it says. Because it says minus 4, that may make you think it's going left 4 where the negatives are, but it's actually going right 4. And the mathematical explanation is that if you set that x minus 4 equal to 0, we're asking yourself, when is this value of x equal to 0? Well, it's equal to 0 when x equals 4. X equals positive 4. And positive 4 is to the right, so it's going right 4. Outside of the function, that controls the y values, and you always do exactly what it tells you, and because it's going plus 5, you know that it's going up 5. So that will change where these asymptotes are. Typically, wait a minute, it's there now. Typically, oh, better move that there. One more time. Typically, the vertical asymptote is at x equals 0, but because this graph has been moving to the right 4, it's now going to be at x equals 4. And the horizontal asymptote is typically at y equals 0, but because this graph is going up 5, it's now going to be at y equals 5. Then the graph is going to look identical to how it normally looks. And there's two different ways that you could use to find this coordinate. I'm going to show just the way that I've always shown since day one. If you're going right 4, that means that you are adding 4 to the x coordinates. And if you're going up 5, that means you're adding 5 to the y coordinates. So the point 1, 1, 1 plus 4 is 5, 1 plus 5 is 6, and with the point negative 1, negative 1, negative 1 plus 4 is 3, negative 1 plus 5 is 4. So I have the point 3, 4. So this is the 1, 1 point, so it's now, it's not at 1, 1, it's at 5, 6. And the other point, negative 1, is now at negative, or not negative 3, 4, just 3, comma 4. Another way of doing it is typically, this point right here is at 0, 0, and you're going to go over 1, up 1 to get to that point 1, 1. Because of this x equals 4 and y equals 5, that means that this coordinate is 4, 5. And if you go over 1, up 1, you would be at 5, 6. And same time, down here, if you went to the left 1 and down 1, so if you went to the left 1, you'd be at 3, and if you went down 1, you'd be at 4. So that's another way of finding those two coordinates without having to do all this business. But remember, because you're graphing, you do need to include either the transformations that you're doing or the XY analysis, what you're doing to the coordinates. Now, it also mentions to find the domain and range. The domain, it's starting, the arrow is pointing all the way towards negative infinity, so it's going from negative infinity all the way up until 4. But then it's not actually reaching 4, so we have soft bracket and soft bracket, and then union. It continues on right after 4, and it keeps going on all the way to infinity. And then the range, it's the same thing, except you think about the y value that the graph will never be, and the graph will never be equal to 5. So it's going to go from negative infinity to 5, union 5 to infinity. And at some point, I talked about when you're doing domain and range, you could do it you could answer it like this. But in this particular case, because it works everywhere except for 4, you could also answer it like this: that the domain is all real numbers, comma, except x equals 4. And then the range would be the same thing. It's all reals except y cannot be equal to 5, so y cannot be equal, except y equals 5. So it works for all real numbers except when y equals 5. Another way of answering it. So okay, so that's graphing. And then the other type of problem that you'd see in here is like this, where it asks for you to write an equation. I noticed in this graph they did not hand write in the asymptotes, so we got to figure that out by ourselves. The horizontal asymptote looks like it's here. The graph kind of levels out right here at -2, so that tells me that this graph is going down 2. If I look at the vertical asymptote, that vertical asymptote is happening at -3. The x value is -3, which means this graph is going left 3. And then how that affects our parent function, y equals 1 over x, left 3, that's always done with an x plus 3, and then the down 2 is always done with a -2, just as we've done with every other function we've done this year. So, alright everybody, that's it. Just a couple of examples of how to do a rational function. If it's indeed Sunday, have a good rest of your evening or rest of your weekend, and if it's Monday, you can look up and say, hey Elliot, happy Monday. But anyway, I hope you're having a good day, and I'll talk to you later. Bye-bye.